Good evening. This is unplanned, obviously, and I think it's just going to YouTube. But I was discussing this earlier this evening with someone and decided to look into it more. Sorry about the voice, got kind of a sore throat. But it seems to me that if you're working with a flat plane and you know an angle and a distance, then you should be able to calculate the height of something using trigonometry. So, on the left side of the screen, I got the basics of a right triangle. Because B represents Polaris. Polaris is it defines true north. If you remember some of my older videos on sundials and things like that, you point them at true north, which is not magnetic north, it's Polaris, because Polaris doesn't move. Now I know from time lapses I did last summer that it seems to move just a slight little bit in a tiny little circle, but for all practical purposes it's not moving across the sky like everything else. Hey, good to see you. Journey's Wake NP Action. This is a sciencey one. Anyway, so Polaris is a fixed point. And at the North Pole, Polaris is 90 degrees overhead. That's how we know where the geographic North Pole is. Yeah, it's been after me for a couple days. Mostly on the right side, makes my right ear hurt. And doing what I can, taking supplements and things, so it's not bad, it's just been a couple days. Anyway, so Polaris is the North Pole, geographic North Pole is defined by the place where Polaris is 90 degrees overhead. And so you have a right angle going straight to the ground from the B point here, Polaris, down to C. This box indicates a right angle, 90 degrees. And the straight line would go to your location, your latitude specifically. Okay, because latitude is really just the angle to Polaris. That's what this curvy line is, the angle. So we have an angle from horizontal to wherever we see Polaris from where we are, that's our latitude. Okay, and Polaris is 90 degrees overhead at the North Pole. So if we know the distance from the North Pole to our location, we can calculate the height of Polaris. So here's all the basic formulas. You can do, more than that, of course, but what we're after is the tangent here, because we know the opposite, or the angle and the adjacent. So we have this side is the opposite, the long side is the hypotenuse, and the adjacent's down here. This is the angle we know, because that's our latitude. Latitude is an angle in degrees. So we know A, and we know adjacent if we know the distance from us to the North Pole. So if we know A and adjacent, then we use the tangent formula. Okay? And the latitude where I am is, you can look it up online. You can go to latitudelongitude.net, which I have here on the screen. I don't know if anybody's really interested, but I don't have my chat up, so I can't post. It won't let me post here in OBS, and I don't feel like working that hard. So anyway, latitude, let's see, it's latlong.net. You would type in the name of a place. Say we do London, England, and sometimes it gives you this ridiculous thing. You do it twice and it works. Latitude is the number here. That's the one we want. So there's how you would find your latitude for any given place, right? Then you also need the distance to the North Pole. So if I say London, calculate distance, it gives me a number. We'll use kilometers. That's what I used. Okay, so we've got our angle going back to here, we've got A and adjacent, right? From those two websites. This one was called distance.to. And then you're going to plug these into this calculator. This is calculator.net, and you do right triangle calculator.html. I think it's .html. Yeah. Anyway, you plug those numbers in, and so you would put the distance in the B box, which is over here on the left, the regular letters A, B, you know, and all that. These over here with the brackets are angles. So we put your distance in the B box, and then the latitude in the angle A box. And then you hit calculate, and it gives you the results, and A up here is the angle to Polaris. Or I'm sorry, the distance to Polaris. It's the length of opposite. So you can see here I got 4648 dot whatever in there. That A is the A here, and that's the height, and that's what we're looking for. So if those things are accurate, and if especially the distance to the North Pole is the bigger if, then you plug in various locations and you should get similar heights, but I don't. Now the one for where I am was 4648 kilometers. Tokyo is 4337, so not too much different, but for some reason London is 5383. So between Tokyo and London, there's a difference of 1,000 kilometers in height. But on the other hand, kilometers is not a big deal, height to Polaris. It's kilometers, not light years. So, you know, and if you wanted to do manual checking, if, you know, double check, you can, the formula is the tangent of the latitude times the distance to the North Pole is the height of Polaris. And if you want to do tangent manually, your calculator doesn't do it, you can go to a link, rapidtables.com, and get a tangent calculator. Anyway, so that's the conundrum, is, you know, given a flat surface, given the angle, which you can check with a sundial, all you have to do is make a sundial, and I've done, like I said, videos on that, and you know that your latitude is your angle to Polaris. The big if is the distance C to A on that triangle. That's the distance between your location and the North Pole, geographic North Pole, not magnetic North Pole, which supposedly is directly under Polaris, so you have a 90-degree angle. So, not sure what to make of that. I only have 3 data points, really only 2 on you know, my text thing on the right, but that's not a lot of data points. What we would need is people from all different latitudes, different longitudes, just for getting a more representative sample. But so there you go. This is something the other people can work on too if they want it. I just thought it was interesting. So anyway, that's all I have. I don't want to talk too much, hurts my throat, but thanks for coming. See you Sunday. I'll be setting up my live stream tomorrow for that, and we're going to talk about the name Jesus and how the Hebrew roots people, which is really is a cult, they're aggressive, they twist the Bible just like Mormons and everybody else does, Jehovah's Witnesses especially, twist the Bible, make up ridiculous arguments about English letters, etc., etc. So we'll do that Sunday. I'll set it up tomorrow.